In 2006, Kawasaki was humiliated. The Suzuki Hayabusa had stolen their speed crown, and there was nothing they could do about it. But deep in their Akashi factory, engineers were plotting the perfect revenge. What they created wasn't just faster than the Hayabusa, it rewrote the entire rulebook of what a hyperbike could be. It's 1999, and the motorcycle world is about to be turned upside down. Suzuki has just unveiled the Hayabusa, a machine so audacious, so brutally fast, that it immediately renders every other motorcycle obsolete. With its 1,299 cubic centimeter engine and otherworldly aerodynamics, the Hayabusa doesn't just break the 300 kilometers per hour barrier, it smashes through it like it's made of paper. For Kawasaki, this was more than just losing a speed record. This was personal. Their ZX14R, known as the ZX11 in some markets, had been the undisputed king of speed since 1990. For nearly a decade, nothing could touch its brutal acceleration and mind-bending top speed. Kawasaki owned the highways, owned the drag strips, and owned the imagination of every speed-obsessed rider on the planet. Then Suzuki came along and made it all irrelevant with one machine. The sting was made even worse by the Gentleman's Agreement of 2000, when Japanese manufacturers agreed to limit their bikes to 299 kilometers per hour to prevent an escalating speed war on public roads. Suddenly, Kawasaki couldn't simply build something faster. They had to build something better, something that would humiliate the Hayabusa in every way that mattered. Curiosity loop. But what was the secret weapon Kawasaki developed that would make the Hayabusa look like a relic from the past? Well, Kawasaki's engineers discovered that they could build an engine that wouldn't just match the Hayabusa's power, it would demolish it in the one place that really mattered: acceleration. And the way they did it would require completely rethinking what a hyperbike engine could be. When Kawasaki's board approved the ZX14 project in the early 2000s, they weren't just commissioning another motorcycle. They were funding what amounted to a corporate vendetta, a technological statement that would restore honor to the Kawasaki name. The project brief was simple: create a machine that would make the Hayabusa obsolete in every measurable way. Lead engineer Hideaki Kanazawa assembled a team of Kawasaki's most experienced engine designers, aerodynamicists, and chassis specialists. Their mission wasn't just to beat Suzuki's numbers, but to understand why riders chose the Hayabusa and then deliver those benefits better than Suzuki ever could. The team spent months studying the Hayabusa's strengths and weaknesses, conducting exhaustive surveys of ZX12R owners, and analyzing thousands of hours of track telemetry data. What they discovered would fundamentally change their approach to building the ultimate hyperbike. Riders didn't just want peak power numbers. They wanted an engine that delivered its power in a way that felt effortless, controllable, and endlessly torquey. The Hayabusa's success came not from being the most powerful bike, but from being the most usable powerful bike. Its engine characteristics made the 1300cc feel manageable, even friendly. Kawasaki realized they would need to build something that delivered even more power while feeling even more refined. This would require engine technology that didn't exist yet. The heart of Kawasaki's revenge would be a 1,441 cubic centimeters inline-four engine that pushed the boundaries of what was mechanically possible in a production motorcycle. But displacement alone wasn't enough. The engine would need to deliver its massive power output with the refinement of a luxury car and the reliability of a commuter bike. The engineering challenges were immense. A 1.4-liter motorcycle engine operating at the performance levels Kawasaki demanded would generate heat that could melt pistons, vibrations that would shake the bike apart, and internal stresses that would destroy conventional components. Every single component would need to be reimagined and re-engineered. The cylinder block was cast from a high-strength aluminum alloy with integrated cooling channels that directed coolant flow precisely where heat buildup was most critical. The pistons were forged from ultra-high-strength aluminum and featured oil cooling jets that sprayed lubricant directly onto the piston crowns during operation, preventing thermal damage even under sustained high RPM use. The crankshaft was forged from steel that was both incredibly strong and precisely balanced. But the real innovation was in the crankcase design. Kawasaki's engineers realized that traditional crankcase shapes created internal air pressure that actually fought against piston movement, robbing power and creating heat. The ZX14R's crankcase featured optimized bypass holes and internal shaping that minimized pumping losses, allowing the massive pistons to move more freely and efficiently. This single innovation was worth nearly 10 horsepower alone, power that came essentially for free through better engineering rather than higher compression or more aggressive tuning. But how did Kawasaki solve the biggest problem that had plagued every previous attempt at building a monster hyperbike engine? The problem was vibration. Every motorcycle engine is essentially a controlled explosion machine, with pistons hammering up and down thousands of times per minute. In a normal engine, these vibrations can be managed through careful balancing and rubber mounting. But in a 1,441 cubic centimeter engine producing over 200 horsepower, the vibration forces become so extreme they would literally shake the bike apart. Previous attempts at large displacement hyperbikes had failed because manufacturers couldn't solve this fundamental physics problem. The bigger the engine, the more violent the vibrations, until the bike became unrideable. Kawasaki's breakthrough was a dual-shaft secondary balancing system that didn't just cancel out vibrations, it predicted and prevented them. Creating the ultimate engine was only half the battle. That engine needed a chassis that could handle its massive power output while maintaining the precise handling characteristics that separated great bikes from merely fast ones. Kawasaki's chassis team, led by Masanori Doko, made a radical decision. Instead of using a traditional twin spar or perimeter frame, they would build a monocoque aluminum frame that treated the entire front section of the bike as a single structural unit. The monocoque design offered several critical advantages. First, it was incredibly rigid, providing a rock-solid foundation for the massive engine's power output. Second, it was lighter than conventional frames while being stronger. Third, it created a slimmer profile that improved rider ergonomics and heat dissipation. But the real genius was in how the monocoque frame distributed stress. Instead of concentrating loads at specific mounting points like traditional frames, the monocoque spread forces across a larger area. This meant the bike could handle the ZX14R's tremendous acceleration forces without flexing or distorting, maintaining precise handling even under maximum acceleration. The frame also incorporated lessons learned from Kawasaki's racing programs. The swing arm mounting points were positioned to optimize chain pull geometry, while the steering head angle and trail measurements were fine-tuned through extensive computer modeling and track testing. Raw power meant nothing if riders couldn't use it effectively. The ZX14R's electronics package was designed to make its devastating performance accessible to riders of all skill levels, while providing the advanced features that expert riders demanded. The Kawasaki traction control system was unlike anything seen on a production motorcycle. Instead of simply cutting power when wheel slip was detected, KTRC used a sophisticated algorithm that predicted when traction loss might occur and adjusted power delivery accordingly. The system monitored throttle position, lean angle, wheel speed differential, and even gear position to determine the optimal power delivery for any given situation. 3 traction control modes allowed riders to match the system's intervention to their skill level and riding conditions. Mode 1 provided maximum intervention for wet weather or novice riders. Mode 2 offered a balance of performance and safety for most riding situations. Mode 3 provided minimal intervention for expert riders who wanted maximum performance with just a safety net. The dual power mode system was equally sophisticated. In low power mode, the engine was electronically limited to approximately 75% of its maximum output, making the bike more manageable in urban environments or for less experienced riders. But this wasn't just a simple power reduction. The engine mapping was completely recalibrated to provide smooth, linear power delivery throughout the RPM range. Full power mode unleashed the engine's complete fury, but even here the electronics worked to optimize the power delivery. Fuel injection mapping was adjusted based on throttle position, engine speed, gear selection, and dozens of other parameters to ensure maximum performance while maintaining readability. Here's where the story takes its most dramatic turn, revealing a secret that nearly destroyed the entire ZX14R project before it ever reached production. During final validation testing in late 2005, Kawasaki's test riders discovered a terrifying problem. The ZX14R was so fast, so devastatingly quick in acceleration, that it was actually dangerous to ride. The bike's acceleration was so violent that it would lift the front wheel uncontrollably, making it nearly impossible to steer or control at full throttle. This wasn't just a minor handling quirk. Test riders reported that the bike was essentially uncontrollable under full acceleration, wheeling so aggressively that steering became impossible and crashes were inevitable. The very success of the engine design had created a bike that was too powerful for its own good. Kawasaki faced an impossible choice. They could reduce the engine's power output, admitting defeat and ensuring the bike would never achieve its goal of beating the Hayabusa, or they could find a way to tame the beast they had created without compromising its devastating performance. The solution came from an unexpected source: Kawasaki's World Superbike racing team. Racing engineers had been working on electronic systems to manage wheelies on the track, and they realized their technology could be adapted for the ZX14R. The result was one of the first sophisticated anti-wheelie systems ever fitted to a production motorcycle. Using sensors that monitored front wheel speed, rear wheel speed, throttle position, and lean angle, the system could detect when the front wheel was about to lift and instantly reduce power just enough to keep it on the ground. But this wasn't crude power cutting. The system was sophisticated enough to allow controlled wheelies when the rider wanted them while preventing uncontrollable wheel stands. It could distinguish between intentional and unintentional wheelies, providing intervention only when needed. This technology saved the project, but it also revealed something profound about the ZX14R's capabilities. The bike was so powerful that it required cutting-edge electronics just to be redeemable. It wasn't just faster than the competition, it existed in a completely different performance category. When the ZX14R finally reached production in 2006, the motorcycle world held its breath. Could Kawasaki's engineering team really have created a machine that would make the legendary Hayabusa obsolete? The first dragstrip tests answered that question emphatically. The ZX14R didn't just beat the Hayabusa, it humiliated it. Where the Hayabusa needed over 10 seconds to cover the quarter mile, the ZX14R consistently posted times in the 9.7-second range. The difference might seem small, but in drag racing terms, it was a massacre. More impressive than the raw times was how the ZX14R achieved them. The Hayabusa required skilled riders who could manage its power delivery and wheelie tendencies. The ZX14R made sub-10-second quarter-mile runs accessible to average riders. Its sophisticated electronics and superior power delivery, making devastating acceleration feel almost effortless. Professional test riders reported times that seemed almost impossible. Cycle World magazine recorded a quarter-mile time of 9.77 seconds at 145 miles per hour. Figures that placed the ZX14R in the same performance category as purpose-built drag racing motorcycles costing 3 times as much. But the ZX14R's dominance extended beyond straight-line acceleration. Its superior mid-range torque meant it could accelerate harder from any speed, making it devastatingly effective for highway passing or canyon carving. Where the Hayabusa felt strong, the ZX14R felt unstoppable. The ZX14R's superiority came from dozens of engineering innovations that individually seemed minor, but collectively transformed the bike's character. The intake system featured individual throttle bodies for each cylinder, allowing for more precise fuel metering and improved throttle response. The exhaust system was designed using computational fluid dynamics to optimize both power output and sound quality. The headers were tuned to specific lengths that enhanced mid-range torque, while the muffler design provided the deep, aggressive note that announced the ZX14R's presence from blocks away. Internal engine components were specified to tolerances that bordered on the obsessive. Connecting rods were individually weighed and matched to ensure perfect balance. Pistons were machined to precise specifications that optimized compression ratio for maximum power output, while maintaining reliability. The valve train featured titanium valves and specially designed cam profiles that maximize airflow while minimizing mechanical stress. Hydraulic cam chain tensioners eliminated the rattle that plagued earlier Kawasaki engines, while ensuring perfect valve timing throughout the engine's RPM range. Even the oil system was revolutionary. A specially designed oil pump provided increased flow to critical engine components, while oil passages were positioned to ensure adequate lubrication even during sustained high RPM operation or extreme acceleration. Suzuki's response to the ZX14R's dominance was swift but ultimately ineffective. The company updated the Hayabusa with minor power increases and cosmetic changes, but nothing that could match the ZX14R's comprehensive engineering superiority. The fundamental problem was that Suzuki had become complacent during their years of dominance. While Kawasaki was investing in revolutionary new technologies and manufacturing processes, Suzuki was content to make incremental improvements to an aging design. The Hayabusa's 1,299 cubic centimeter engine, once groundbreaking, suddenly seemed old-fashioned compared to the ZX14R's high-tech 1,441 cubic centimeter power plant. Suzuki's conventional frame design felt crude next to Kawasaki's sophisticated monocoque construction. Even the Hayabusa's famous aerodynamics seemed less impressive when the ZX14R proved that raw power could overcome wind resistance through sheer force. Industry insiders revealed that Suzuki had been caught completely off guard by the ZX14R's capabilities. Internal company documents showed that Suzuki had expected Kawasaki to build a bike that was marginally faster than the Hayabusa, not one that would completely redefine the hyperbike category. The ZX14R's introduction changed more than just dyno charts and dragstrip times. It fundamentally altered how manufacturers approached hyperbike development and how riders thought about ultimate performance motorcycles. Before the ZX14R, hyperbikes were essentially powerful engines mounted in adequate chassis with minimal electronics. The focus was on peak power numbers and top speed claims. The ZX14R proved that true hyperbike performance required a holistic approach that considered power delivery, chassis dynamics, and electronic systems as equally important elements. Other manufacturers were forced to completely rethink their development strategies. Honda's subsequent VFR 1200 incorporated lessons learned from the ZX14R's success. BMW's S1000RR featured electronic systems that were directly inspired by Kawasaki's innovations. Even Ducati's Panigale showed clear influence from the ZX14R's integrated approach to performance. The bike also changed rider expectations. Suddenly, having just a powerful engine wasn't enough. Riders expected sophisticated electronics, refined power delivery, and comprehensive engineering that made ultimate performance accessible rather than terrifying. Looking at today's motorcycle landscape, the ZX14R's influence is everywhere. Electronic traction control, anti-wheelie systems, multiple power modes, and sophisticated engine management have become standard features on performance motorcycles across all categories. https://share.google images GQ YOWEL FTF XRWLPAK. The monocoque frame, design pioneered on the ZX14R, influenced everything from sport bikes to adventure motorcycles. Manufacturers realized that structural efficiency wasn't just about saving weight, but about creating a foundation that could handle the stresses of modern performance while improving rider experience. Even Kawasaki's own subsequent models showed clear evolution from the ZX14R's innovations. The supercharged H2 models used lessons learned from the ZX14R's development to create bikes that were even more powerful while remaining controllable and rideable. The ZX14R's production run lasted over a decade, during which it consistently outsold the Hayabusa and established itself as the definitive hyperbike. Performance figures remained impressive throughout the production run. Even as other manufacturers introduced newer, more advanced models, the ZX14R's fundamental engineering superiority kept it competitive. The bike's ability to consistently produce sub-10-second quarter-mile times became legendary among drag racing enthusiasts. Reliability statistics showed that Kawasaki's obsessive attention to engineering detail paid dividends. The ZX14R achieved reliability ratings that exceeded many smaller, less powerful motorcycles, proving that ultimate performance and long-term durability weren't mutually exclusive. The real secret behind the ZX14R's insane engine wasn't any single technology or innovation. It was Kawasaki's decision to approach hyperbike development as a complete engineering exercise rather than just a power race. While Suzuki focused on maintaining their existing advantage, Kawasaki reimagined what a hyperbike could be. They didn't just want to build a faster Hayabusa, they wanted to create a completely new category of motorcycle that would make the Hayabusa seem primitive by comparison. This philosophy drove every aspect of the ZX14R's development. The engine wasn't just bigger and more powerful, it was fundamentally more sophisticated in how it delivered that power. The chassis wasn't just stiffer, it was designed to work in harmony with the engine's characteristics. The electronics weren't just add-on features, they were integral to the bike's ability to function as intended. The result was a motorcycle that didn't just beat the competition in specific measurements, but redefined what measurements mattered in the first place. The ZX14R proved that true performance superiority came from comprehensive engineering excellence rather than individual component advantages. So here's my question for you. If you were building the ultimate hyperbike today, what would be your secret weapon to dominate the competition? Drop your thoughts in the comments below. I genuinely want to hear your take on where hyperbike technology is headed next. And if you enjoyed uncovering the engineering secrets behind one of the greatest motorcycles ever built, smash that subscribe button for more deep dives into motorcycle legends.